So hello and welcome to my YouTube channel. In this video we are going to discuss about the season trees and what are the purpose of using the season trees. So when we talk of the season tree, here we know that a decision tree is having a structure just like a normal tree in data structures. But when we talk of a decision tree, it is a tree that supports uh, for classification purpose and regression purpose. So we call it a decision support tool that will use a tree-like graph or model for decisions and their possible consequences are included. It will tell us what are the possible events, outcomes, and what will the source cost and all other utilities can be identified with the help of decision trees. So it is just a way to display an algorithm that only contains conditional control statements. It's a flowchart like structure in which we are having internal and external nodes, where on the internal nodes we have the test conditions and on the external nodes, that is on the leaf nodes, we have the resultant output. There is a path from the root to the leaf that is known as classification rules. So decision trees are also known as CART, where CART stands for classification and regression trees. It is a supervised learning model which has high accuracy. Stability is also high and very easy to interpret because while looking at a tree we get very good information and very easy to interpret the results from that. So as its name suggests, it is used for both classification and whereas regression purpose. The possible solutions in this case to a given problem emerge as the leaves of a tree. Each node represents a point of deliberation and a decision. So this is a simple decision tree for checking out the credit risk and all such things. So in this case we are having the root node and these nodes are my decision points, and based on these decision points they are also known as internal nodes, which is checking if the saving is low, medium, high. So three questions are there, so low, medium and high, three branches will be there, and based on that a decision is being made, like there is a bad risk or good risk and all such things. So this is a structure for a decision tree where root node is the topmost node of the tree, which is also known as a parent node in this case. And we have these branches where these branches represents an outcome of the test of the training data set. And these nodes which are having certain children like this one and this, these are the internal nodes that will denote a test on an attribute. And the leaf nodes basically hold numerical prediction, which may be a class that is for classification, and some continuous values decision, that is in a regression case. So we are having a root node that represents the entire population or sample, and it is further gets divided into homogeneous sets. We have the terminology of splitting in decision trees, which is a process of dividing a node into one or more subnodes. We have the decision node, that is the internal node on which the condition is there, which is used when a subtree splits into further subnodes, and which is also known as a decision node. We have leaf node, also known as terminal node, which will not separate further and will give us the final result of the conditions in the decision trees. Pruning is a process when we remove subnodes of a decision tree, and we can do the opposite process, that is splitting. So splitting is dividing into this, and pruning is removing the subnodes. We have branch and subtree. We know that a subtree section of entire class is called branch or a subtree. We have parent and a child node. A node which is further divided into subnodes and having children is known as parent node. Decision trees has application when we have if then else construction that will fit it for programmatic structure. They are very well suited for the categorization problem when we have to categorize the data into multiple classes or multiple species, like species of flower, species of animals. Certain grade system is there in which we can say we are can divide the data into categories, that is classification we can use decision trees. They are very simple. Tree diagrams have been used in a broad range of industry disciplines, which include civil engineering, energy, financial engineering, healthcare, paramedical, education, law, and business. So it is used in almost all the application areas. Evaluation of brand expression opportunities uses for business historical sales data. Determination of likely buyers of a product using demographic data which enable targeting limited advertisement budget. Prediction of likelihood of default for applicant borrowers using predictive modeling can uh, also be done using historical data. So similarly, we have applications for patient treatment and operational research. Decision tree has a number of applications. So it works both on categorical and continuous variable, which give us the idea of splitting the data into continuous and categorical variable. Based on that, we get two types of trees: the categorical variable decision tree and the continuous variable decision tree. So when we talk of categorical variable trees, this is the process that is known as classification trees, and this is basically regression trees. So we have already discussed that the decision trees are also known as CART algorithm, that is classification and decision tree algorithms. So when we talk of a categorical variable, this is the process of dealing with classification, and when we talk of continuous, we are talking about the regression problem. So when the decision tree has categorical target variable, it is known as categorical decision tree, in which the answer in the form of yes, no, true, false, positive, negative, and more than one category, two categories can also be there. So not limited to binary classification, it can be further having multiple applications. So when we talk of continuous variable, they are for regression purpose, in which the target variable is continuous. So based on this, it has been said that when we talk of categorical variables, these are using the method of mode, and when we talk of continuous and variable decision in which regression is being performed, they will provide the result in the form of mean. So when we talk of the algorithm, it simply places the best attribute of the dataset as a root node. It means the root node is decided which is having the highest information gain. So based on entropy and information video, there is one more video available on my YouTube channel for entropy and information gain. A separate video is there. So if you have any doubt for information gain or entropy, and then you can watch that video. So split the training set into subsets. Subsets should be made in such a way that each subset contains data in the same value for an attribute. So we have few assumptions in case of decision tree, like at the beginning the whole training set is considered as root, and future values are preferred to be categorical, and if the values are continuous, they are discretized prior to building the model. Records are distributed recursively in the manner, and order of placing the attributes as the root or internal node of the tree is done by using statistical approach, in which we use the process of entropy and information gain. So regression tree and classification trees are a part of decision tree algorithms, which is based on categorical and continuous variables. So strength of decision trees are they are able to generate understandable rules. The decision trees perform classification without requiring much computation. Decision trees are able to handle both continuous and categorical variables. Trees provide a clear indication of the subfields and, most important, the prediction and classification. Talking of weakness or the limitations of decision tree, they are less appropriate for estimation task, in which we have the option of using random forest trees. So decision tree are prone to errors in classification problems with many classes, and when if we have relative number of training examples are small, then this gives a bad result. They can be computationally expensive, as we will see in the numerical problem. Lot of computation is required. The process of growing a decision tree is computationally expensive. Each row splitting is required based on the information gained, so we have to do multiple computations in this case. So we will see in the numerical of decision trees video how they are computationally expensive. So thanks for watching the